Hello, I want us to look at Computer Studies Form 4, that is Questions and Answers. The covered topics are the four main topics in Form 4. We have the Introduction to Networking and Data Communication. We have Application Areas of ICT. We have Impacts of ICT on Society. Then we have the Career Opportunities in ICT. So basically, the first question that we shall post for ourselves is to define the main terms. We have computer network, we have data communication, we have data signal, and also we have signal encoding. When you talk about a computer network, somebody will ask you, what is a computer network? Basically, it is just an interconnection of devices, and these devices can be computers, servers, printers, or other peripheral devices. In Form 1, you looked at peripheral devices. They are devices that are attached to the system unit. Remember, the connection can be wired or wireless. Then we have data communication. Remember, the purpose of a computer network is data communication. And therefore, data communication, this is just exchange of digital data between two or more devices through a transmission media. Remember, transmission media can be wireless or wired. Then we have data signal. When you talk about data communication, we are basically transmitting data signals. So a data signal is a physical representation of digital data that is transmitted over a communication channel. Then we have what is signal encoding. Signal encoding is just the process of converting digital data into a format suitable for transmission over a communication channel. Therefore, these terms are actually explaining what happens between wires or wireless media. Then, somebody may ask you, what is the difference between a stand-alone and a networked computer? Just like the word goes, stand-alone. This means it is a system that is not connected to others. That's why it's called stand-alone. Whereas the opposite is networked computer. So a computer that is in a network is a networked computer, and then the opposite, the computer that is not in a network, it is alone, then it is standalone. Then we have, using an illustration, explain the digital and analog waves. Therefore, the first one here is an analog wave. Then the second one, which is non-continuous, as you can see, this is digital signal. But the one that is continuous here is analog signal. Then a signal wave has three main properties: frequency, wavelength, and amplitude. This is a bit of physics, but when you talk about a frequency, frequency is the number of circles, the number of oscillations of a signal wave. It is measured in hertz, that is capital H, small z. Then we have the wavelength, the distance. This is the distance between two consecutive corresponding points on a signal wave, such as a peak to peak. So when you talk about this point and this point, this point and this point, you're talking about a wavelength. Then you have the amplitude. When the wave is displaced, the maximum height that this wave goes or rests in that position is called an amplitude. So an amplitude is the maximum displacement or the height of a signal wave. Then number 5, differentiate between the following. We are differentiating between a signal modulation and demodulation. Then we have modulation rate and bound rate. We have bandwidth and throughput. We have baseband and broadband. So basically, when you talk about a signal modulation, this involves altering. To alter is to change one or more properties of a carrier signal, such as amplitude, frequency, or phase, to encode information onto it. So basically, when you talk about modulation, it is actually changing. Like, for example, when you change a digital signal to analog signal, then you are doing signal modulation. The modulation is converting back or reverse process of modulation. So the modulation is now changing. If you had changed digital to analog, then you are now changing back analog to digital. Then we have modulation rate. This refers to the rate at which the carrier signal is modified or modulated. Just like the word goes, modulation rate. This is the speed at which, that is the rate, when you talk about the rate. Then we have bound rate. On the other hand, this refers to the number of signal symbols transmitted per second. That is the bound rate. Remember, this is the number of signal symbols transmitted per second. Then we have bandwidth and throughput. Just like we can talk about a pipe that is transporting water. The amount of water that can be pumped to a pipe, that is the can be equated to bandwidth. Bandwidth is the amount of data that can pass through a transmission signal. Then throughput, on the other hand, is the actual data transfer rate achieved in a communication system. Remember, in my notes, if you go through these notes of mine, realize that there are some parts that probably I'm not reading, but for your understanding and for your content, make sure you read everything. For me, I'm just actually going through trying to simplify the whole stuff. Then we have baseband and broadband. When you talk about a baseband, this is a digital signal. On the other hand, a broadband is an analog signal. That is the simplification of the whole story that goes here. Then we have question number 6, to make the most of or to optimize. Some other guys will say to optimize communication channel, or to make the use of, or make most of. Okay, so to optimize communication channel, many signals are sent through using either frequency or time division techniques. So we have these two ways of optimizing, of make use of a communication channel. So state the name given for these techniques. The second point is using an illustration or diagrams, explain how these concepts work. So basically, guys, here we are talking of multiplexing. Multiplexing, just like you can see this diagram, there are so many gadgets that are transmitting data, but these gadgets need not to have a direct connection to the recipient. So to avoid that, we have a gadget called multiplexer. Multiplexer brings together all the signals, then they are transmitted using one single channel. Then when they reaches the destination, they are demultiplexed. They are again separated. Remember, these ones, they use the IP addresses and other special addresses to identify the recipient. So basically, this diagram here is explaining the multiplexing technique, and I have just explained. So in your exams, most of the stuff like this one, you can just use a diagram. You can get this document from the URL that I have given there. Then, during data transmission from a source to a destination, it could face challenges that may cause it to get lost. Highlight these challenges. So here we are talking of the challenges or the hindrances or the handles that appear when data is being transmitted. So the first one is attenuation. Attenuation is weakening of signal as distance increases. But in physics, there are some jargons or vocabulary used, like attenuation refers to decrease in signal strength. But just to make it simple, just say attenuation is weakening of signal as distance increases. Then we have noise. When we talk about noise, in the context of telecommunication and signal processing, noise refers to any unwanted or random interference that disrupts the transmission or reception of the signal. Simple and clear. You can just understand that noise is any interference that may affect data. Remember, you need to transmit data in a clean way. Then we have dispersion. What is dispersion? Dispersion is a phenomenon where a signal spreads out over time or space as it travels through a media. Remember, this is a disruption. We're talking of dispersion. Just like in a normal English, to disperse is actually to make something spread. So, in optical fibers, for example, dispersion can occur in two main forms: chromatic dispersion and modal dispersion. Okay, we don't need to really go much that is in details, but for your own understanding and for content, to have the content, make sure you read more on that. Then we have delay distortion. What is distortion to start with? So when you talk about delay distortion, it is also known as intersymbol interference, or ISI, occurs when different parts of transmitted signal arrive at the receiver with varying delays. This delay discrepancy can result from factors such as multipath propagation, where the signal takes multiple paths to reach the recipient. So these are some of the challenges or hurdles that affect data transmission. Explain the importance of repeaters in a communication system. Guys, just like the word goes, repeater. To have a repeater, a repeater is actually something that is repeating. So in a nutshell, a repeater is a gadget that regenerates the signal. When the signal is affected by attenuation, the repeaters propagate or really amplify. Actually, that is the term. It acts as an amplifier. So the importance of a repeater is to amplify or regenerate the signal when it weakens or when it is affected by attenuation. Then we have question number 9. Explain the following data communication modes. Remember, we have the following 3 modes. We have simplex, we have half duplex, and we have full duplex. So simplex is the first, just like the word goes, simplex, from the word that is from the word simple. Simplex here, in simplex communication, data travels in only one direction. For example, we are talking of a television. When you are listening to news or when you are watching a movie from a television, you cannot really ask questions. You can only watch. So when we talk about data transmission in one direction, like in TV broadcast or radio broadcast, it is called simplex. Then we have the half duplex. Half duplex is communication in both directions, but one at a time. Like for example, when 2 policemen are actually communicating, they have to say over. So one policeman speaks, then say over, so the other one can take over. That is half duplex. It is transmission in both directions, but one at a time. Then we have our common communication or data transmission, that is full duplex. Full duplex is communication simultaneously. For instance, when you are speaking to your friend using a mobile phone, you can both hear each other. That is, you can talk simultaneously. That is full duplex. Then we have 4 reasons why computer networks are important. Number 1 is communication. Computer network is important for communication. Remember, communication is exchange of data between the sender and the recipient. You can give an example of an SMS or an email. Then we have resource sharing. In a circumstance like in an office, some gadgets are very expensive than like the printer, scanner, and storage devices. So instead of buying each for each machine, you can just network them for resource sharing. Then for data sharing and access, when you have data somewhere and you want to make a decision, you can just go there and have data. Like for example, when you want to get data from the internet or from Google, the network make it easy for you. Then we have remote access, remote communication. When you have computer network, you don't really need to move from one office to the other. You can just communicate using the network. Then you have business operations. You can have e-commerce and others from the internet. There is global connectivity. Global here means the world. It is communication without really moving, without really taking an aeroplane to go to UK, to London, to go to Nigeria. You just go to your network and communicate. So there are others there. Also, you can talk about a very important aspect here, entertainment and media. This is made possible. You can go to YouTube and other channels to get entertained. Explain 6 limitations of networking as rant. So networking is very expensive. Remember a station whereby you want to install Wi-Fi in your house. You can see how expensive it is. Security concerns. Some people may hack, may get unauthorized data and misuse it. You can have malware attack, that is viruses. You can have eavesdropping, that is some people trying to monitor or listening to your conversations. Then we have bandwidth limitations. You can talk about network bandwidth refers to the capacity of network to transmit data. Bandwidth limitations can lead to network congestion, slowdowns, etc. So when bandwidth is slow, then you may not probably get what you want. You hear people saying it's hanging. Then we have reliability and availability. Sometimes network may not be available. You hear your friend saying today there is no network, so that is a limitation. Then we have compatibility and interoperability. So here you're talking about gadgets not working versus another gadget, that is compatibility. Then interoperability here, we are talking of different probably networks not really merging with each other. Then we have scalability, that this is expandability. Probably you may have a limitation whereby you cannot hotspot more than 5 gadgets, but you are 10. So you can see that is scalability. There is no way you can expand the network. That is a disadvantage. Then maintenance and management, it is costly. Explain the following types of network. We have wide area network, WAN. We have local area network, that is LAN. We have MAN, or metropolitan area network. When you talk about wide area network, we are talking about the worldwide network. This is a wide area network. When you talk about a local area network, this is just a limited network. Like for example, when you're talking about network on a building, like KICC, when you're talking about a building or a school, your school, you can take the network in your school. That is a local area network. When you talk about a network in a town or in a city, that is metropolitan. List examples of wide area network. Remember, wide area network, we have said this is a network over a very large area. So we can talk about the internet. You can talk about global corporate networks. You cannot talk about the telecommunication network. That is a very good example. Then you can talk about cloud computing networks. You can talk about financial networks, like something like M-Pesa. It's actually a big financial network. You can talk about government networks. You can talk about educational networks and also health networks. So in your free time, or when you are going through this video, you can just pause and take some notes. Then we have explain briefly 3 elements of networking. We have devices. You cannot network without devices. We have communication software or protocols. Then we have communication media. That is bound or non-bound. Some people may say wired or wireless. So list 4 types of guided transmission. When you talk about guided, we are talking about bound or wired. So we have 2-wire open line cables. We have twisted pair cable. We have coaxial cable and fiber optic. Remember, fiber optic is among the upcoming or the latest technologies in wires and most used nowadays. So using illustrations, differentiate between unshielded and shielded twisted pair cable. When you talk about unshielded, we are talking about UTP cable. You will hear your teacher talking of UTP. Then we have the STP, that is the shielded twisted pair cable. So these are the 2 cables. You can have the outer cover. This one, the shielded, it has this shield here. You can see the difference, but this one doesn't have the shield. It just have the coating. So they have differences. Make sure at your free time you read about them in details. Then we have, with an aid of a diagram, describe the physical structure of coaxial cable. Remember, these are some of the cables that you use, like the one you use for television aerial. So it has the copper core, insulating material, braided outer conductor, protective plastic covering. So In an exam, somebody may ask you to draw and label coaxial cable. Then we have these two types of cables, where we have the V-net and thick-net coaxial cables. So the difference between the two is, as you can see, the thick-net here, it has the braided shield outer covering, but if you look at it, this one is more protected. You can see the layers 1, 2, 3, but this one has actually 2 layers. So you can also practice how to draw these two types of coaxial cables, that is the V-net and the thick-net. Discuss how a fiber optic cable transmits data. Basically, you can see what happens. Fiber optic transmit light rays. So the light rays keep on reflecting, just like this diagram shows here, on the cladding. So fiber optic cables transmit data by converting digital information into modulated light pulses generated by a light source like a laser or light emitting diode. These pulses travel through the core of the fiber optic cable, which is surrounded by a cladding layer that ensures total internal reflection, minimizing signal loss. So you can pause the video and take some short notes on this, but in an exam situation, even if you draw this diagram showing how the reflection takes place, you'll still score some marks. State 5 advantages of using fiber optic as a transmission media. Number 1 is that it has a high bandwidth. Remember, we have covered what is a bandwidth. It transmits terabytes per second, that is megabytes, hundreds of megabytes, that is terabytes. So it's very fast. Then low attenuation, we have talked of attenuation as the weakening of the signal. Also, it is immune to electromagnetic interference or noise. Then security, it has a good security. It is difficult to tap the information. Then lightweight and small in size. You can also see it is portable. That is what that one says. Differentiate between Bluetooth and infrared transmissions. So when you talk about Bluetooth operates using radio waves, using, that is the speed of or frequency of 2.4 gigahertz. Whereas we have now the infrared. The infrared transmission relies on light waves and has a significantly shorter range of a few meters. Then the transmission rates, you can see it's typically 115 kpbs to 4 mpbs. Then we have the next question. Using an illustration, explain how data is transmitted on terrestrial microwaves relay station. So it works on the line of sight. You can see here we have the transmitter station and the receiver there. So we have point-to-point microwave. That is, they must have a line of sight, no obstacles. Then define the following terms. We have communication satellite, uplink, geostationary satellite, satellite footprint, and downlink channel. So a communication satellite is an artificial satellite stationed in space to relay communications signals such as television, radio, internet, telephone data between various locations on Earth. So later on, we shall see below this video, we shall see how that communication takes place. Then we have geostationary satellite. This is a satellite position in a fixed point above the Earth, Earth's equator, maintaining the same relative position to the Earth's surface. So this is a satellite that is on the space. Then we have uplink. Uplink refers to the transmission of data from Earth to the satellite. So you can just, when one of the satellite is transmitting to the geostationary station, that is an uplink. But when the geostationary satellite or station is transmitting from the space to the Earth, that one will be downlink. Then we have the satellite footprint. The satellite footprint refers to the geographical area on Earth's surface covered by the satellite signal. So the area covered by a satellite signal is the satellite footprint. I have explained what is a downlink. So guys, look at this diagram. Here we have the ground station. Like for example, I have taken this one. We have the USA, United States of America. Then we have Europe. So somebody wish to transmit a signal or something. So we have the geostationary satellite up here. This is an uplink. Then we have now the satellite now transmitting to Europe. That is the downlink. You can see here we have the Atlantic Ocean. This is a very good diagram explaining what happens when a satellite is transmitting data. Explain the use of the following network connectivity devices. We have the NIC, that is Network Interface Card. We have Intelligent Hub, Repeater, Modem, Bridge, and RAN, that is Local Area Network Switch. Now, the point of interconnection, the point where the cable, the internet cable, connects the system unit is the network interface card. Then we have the hub. The hub is a multi-port. It's a multi-port device. Like for instance, if you in your computer hub, computers are connected. They are connected using cables. These cables connect each other from a gadget called hub, a multi-port device. Then we have a repeater. We had seen what is a repeater. Then we have a modem. A modem is just an acronym for modulator, demodulator. It is a device that modulates digital. This is just a gadget that converts digital to analog and analog to digital signals. Then we have a bridge. A bridge is a networking device that connects multiple networks. You see, if you bring a computer and then this computer you put two NIC, that is network interface cards, then one cable comes to the first NIC, then another cable comes from a different network, then that machine will be referred as a bridge. Then we have an intelligent hub. The difference between an intelligent hub and a hub is that this one has a database. It has a database that keeps, it keeps the details of some exchange of data, just like a router. Then you have the RAN, that is the local area switch. It is a networking device that operates at the data link layer 2 of the OSI model. Later on we shall see the layers of OSI model, but that doesn't mean that you may not grasp what is a local area network switch. Give 5 functions of a router. So a router is responsible for packet forwarding, network address translation, we call it NAT, firewall services, and also quality of service. When we talk about the quality of service, we are actually trying to deal with the network traffic. How much good is the network traffic? Then you have virtual private network, or VPN. These are private networks. Private networks are made possible by adjusting or configuring a router. State 3 categories of networking software. Networking software is classified into 3. We have network operating system, or NOS. We have network protocols, and then we have now the network security software. So these are the 3 categories of networking software. Don't forget, it must have its operating system. It must have some rules for governing communication, that is the network protocols. And then these protocols must be protected, and therefore we have network security software. Then briefly, describe the OSI model. When you talk about the OSI model, it is a conceptual framework used to understand and standardize the functions of telecommunication and the computing system. It consists of 7 layers. You can just try to come up with a way of grasping this. Right now, we can talk about absent NDP. That is, we usually start from the physical layer. Then we go to second layer, is called data link layer. The third layer is called network layer. Then we have transport layer, session layer, presentation layer, and lastly we have the application layer. You can just pause this video and probably take some short notes on the OSI OSI model. Then we have explain the use of the following protocols. Remember, the term protocol means the rules that govern communication between machines in a network. That is protocols. The most common protocols are TCP, Transmission Control Protocol, SMTP, that is Simple Mail Transfer Protocol. Then we have File Transfer Protocol, FTP, and Internet Protocol. These are the most common protocols. So, Transmission Protocol provides reliable connection, oriented communication between devices. So, just like the saying goes, transmission, it just make the connection reliable. Then we have Simple Mail Transfer Protocol. This one is responsible for sending and receiving of emails. That's why we are bringing the term email. Then we have the File Transfer Protocol. It is responsible for transferring files. Just try to see how I'm explaining. You don't need to write so much. Just try to understand what the protocol does. Then you have the Internet Protocol. This one is responsible for routing packets of data across network boundaries. Don't have so much. Just try to understand exactly what the protocol does. Using examples, differentiate between logical topology and physical topology. When you talk about the physical topology, it is the actual layout, the way you can see with your eyes. But the logical topology is how data is transmitted. You cannot see. But physical, it is actually the arrangement. So we usually have the bus topology. The devices are in a linear fashion. Then we have star. Devices are connected using a hub or a switch. Then we have ring, just like a ring, something round. All gadgets are connected to each other. Then we have mesh, whereby all gadgets are connected, all paths are occupied. You shall see the diagrams later on. Then we got logical. Logical, we have said this is how data flows. You cannot really see. And here we usually have the following. We have Ethernet and token ring. So when you talk about the Ethernet, devices communicate using Ethernet protocol, which includes rules for addressing and encapsulation of data and error detection. So here it is assumed that when a computer wants to send data, it listens to the cable, and when the cable is free, then it releases the token or the data. When the cable is not free, it waits until the cable is free. When you talk about a token ring, it is assumed that data is packaged or put in a token or like an envelope, then released with an address of the recipient, and that is the receiver. So the data is released in the cable, and when it goes to computer A reads. If the address is not it's not his or hers, then it releases to the next machine. That is the token until it reaches the destination. Then we have the Internet protocol here. Devices communicate using IP addresses. This is the Internet protocol. Yeah, we are talking about devices communicating using IP addresses. So guys, here you can look at this one. We have the bus topology. There is the backbone cable. Then machines are connected to the backbone. And also you can see there is a printer here. Then we have a terminator. At the end of this, the network, we must have a gadget called a terminator, which can be a computer or any other gadget, to prevent bouncing back of the signals back to the network, bringing noise and distortion. Then we have ring topology. You can see these are peers. Each machine is connected to each other in a ring format. Then we have the star topology. You can see all gadgets are connected to the router or switch. This looks like a star. Then we have the mesh, the full mesh topology. You can see I have really acknowledged where I got these photos. You can see the websites. So we have the mesh. You can see these computers. Each machine is connected to each other. Okay, we have food for thought. Give advantages and disadvantages of all the above topology. That is your assignment. Then briefly differentiate carrier sense multiple access. That is the CSMA/CD. and career sense multiple access with collision avoidance. That is the acronyms there, or the abbreviations. So what happens when we are talking about career sense multiple access with collision detection? Just like the word collision, we have the collision, not the career, collision detection. When the computers are transmitting data, we have said using the Ethernet, the computer resends to the cable. Assume we have two machines transmitting data, machine A and machine B. Machine A detects that the cable is free and then releases the token or the data. Machine B, on the other hand, might have detected a free cable and still transmitted data. What happens? This data brings collision. And therefore, when this collision happens, each machine calls back its data and waits until the cable is free, then transmit. So, on the other hand, we have the collision avoidance. Just like I have explained, these machines try to avoid collision by use of avoidance mechanism to make sure that the network at all time it's flowing without really hanging or having collision. So you can just pause the video and take few notes. We proceed to our next topic, application areas of ICT. Here we don't have much questions. So the first question is, state 4 types of financial systems that can be automated using ICT. So the first one is budgeting. You can automate budgeting system. You can automate accounting system. You can automate banking system. You can automate auditing system. The next one is identify the main components that make up electronic point of sale or EPOS. Guys, you have ever visited a supermarket, and whenever you take your goods from the supermarket, you pay them at a certain point where you get the teller or the cashier. That point is called the EPOS. So the EPOS, when we go to the EPOS, there are various gadgets or hardware that you get there. You get a monitor, you get input devices like touch screen, keypad or keyboard. Then you can get the barcode scanner. The barcode scanner is part of the EPOS. We have card reader, and also we have the cash drawer, and lastly we have the receipt printer. So you can try to visualize how the EPOS looks like. When I talk about it, it has the monitor, touch screen, barcode reader, card reader, cashier drawer, and the receipt printer. So state 4 advantages of using EPOS system in a retail store or a supermarket or a shop. So it brings faster processing of transactions, automatic update of inventory, automatic triggers for shelf restocking and reordering of new stock, uniform price enforcement for all customers. You can imagine a situation whereby somebody is bargaining a sweater, but when you go to where EPOS is, if a sweater is 1,000, then every customer is sold 1,000 without really bargaining. Number 4, identify 4 types of computer-based learning. This is a very important sector. We have the computer-aided instruction, CAI. We have computer-aided learning, CAR. We have electronic learning or e-learning. We have computer-based simulation. Remember, guys, this is a very examinable part. What is computer-aided instruction? This refers to the use of computers to deliver education content and facilitate learning. You can get a situation whereby you have a software with quizzes and exercises. So you don't really need a teacher. Here, you just go to a computer, log in, you are posted quizzes and exercises, and then the machine times for you and marks for you. That is the computer-aided instruction. On the other hand, we have computer-aided learning. What is the difference now between the other one and this one? Okay, this one encompasses a broader range of education activities supported by computers, including both instruction and learning process. Computer-aided learning integrates technology into various aspects of running process, such as accessing educational materials or resources, collaborating with peers, completing assignments, and receiving feedback. It emphasizes the role of technology in empowering learners to take more active roles in the education, to explore topics at their own pace. So here you can just rewind and rewind and rewind. Like for example, you may even have a WhatsApp group where, or something like Google Classroom. You are really collaborating even with other peers and trying to complete the syllabus or the curriculum the way it is designed. Then we have electronic learning. Here you can talk about using educational apps, digital libraries, virtual classrooms. You can use CDs and DVDs with the educational materials, such. So we can talk about e-learning. Then we have simulation. Simulation is actually trying to do something in a virtual world, trying to okay, some people may just say you are trying to do an experiment that probably might be dangerous in a real life situation, but you are trying to do it using a software or such. So computer-based simulation involves the use of computer programs to replicate real-world scenarios or processes for educational purposes. So you can simulate something like titration or any other experiment. What is the meaning of a digital library? What is a digital library? A digital library is a collection of digital resources organized and accessible through electronic means, typically over the internet or on a computer network. These resources can include various types of digital content such as text, images, audio, files, videos, datasets, etc. You can also try to search from YouTube, that is the digital libraries. YouTube can also be termed as a partial digital library because I actually use it for learning. You can also see you are using YouTube for really learning these topics. Differentiate between internet and World Wide Web. Some people just get it difficult to differentiate between www, that is the World Wide Web, and the internet. So the World Wide Web, commonly known as the web, is a system of interconnected hypertext documents and resources accessible via the internet. So the World Wide Web may not be there if there is no internet. So what is internet? Internet is a global network that connects millions of computers and other devices worldwide. So try to get the difference between these. It is just like a vehicle. Take a situation whereby you have a lorry and you add the road. So internet is the road, the lorry is the World Wide Web. So that's the difference. The lorry cannot travel without the road. So that one makes you understand better. Using an example, explain non-destructive testing as conducted in manufacturing industry. Non-destructive testing here brings the whole thing of simulation. So this is the creation of a virtual model that emulates or imitate a real-world situation. Like for example, you can simulate a car crash. What will happen when two vehicles collide head-on? So instead of bringing two vehicles, which will be very expensive and very dangerous, you just simulate that one. What will happen if two cars collide head-on? So that one is called a non-destructive testing. You are either using models instead of using real life. Then state 4 advantages of computerized simulation and modeling. Number 1 is cost saving, just like I had explained earlier. Then we have time efficiency, that is, it saves on time. Then we have insightful analysis. This means simulation and modeling tools provide detailed insights into complex systems and phenomena that may be difficult to observe or measure in the real world. Like for example, engineers can analyze factors such as stress distribution, fluid dynamics, thermal behavior, and structural integrity with precision and accuracy. Then we have risk mitigation. By simulating various scenarios and analysis potential outcomes, organizations can proactively identify and mitigate risks associated with the product development, manufacturing process, and operation. So for here, you are trying to reduce the risk. That is the risk mitigation. You are trying to reduce the risk before it happens. Just like we usually have an insurance to cater for uncertainties. List the 5 application areas of ICT in transportation. So you can talk about air reservations, shipping control systems, tracking systems, automobile control systems. Also, you can add this one. We have traffic management systems. You can still pause and read more. We have intelligent transport systems. We have fleet. Fleet is road or luggage, mizigo. Fleet management systems. Then we have public transport system. You can read how I have really explained, but all these, they fall under this. They fall under the points that I have summarized up here. So in an exam situation, you can just pick these: air reservation, shipping control system, tracking system, out research. Then try, for example, to explain a bit. List some unique biometric features that security and law enforcement agencies can rely on to uniquely identify people using biometric systems. So you can talk about fingerprints, iris color, facial features like eye, nose, cheekbone, triangulation. So these are some of the features that a biometric may check. Explain the components of an expert system. An expert system is a system that works like a human expert. So what are the parts of an expert system? We usually have the knowledge base. This is where actually the rule, facts, and procedures are stored. We have the inference. Inference is a conclusion. So if you are talking about an expert system, like a computer game, like chess, something like checkers. Let's talk about chess. When you are playing chess or any other computer game, you can see it has all this. It has the knowledge base, where that is where the rules, facts, and procedures are. It must make a conclusion that the game is over, or whether you defeat it or you are defeated. That is the inference engine. This is the one that draws conclusions. Then, where do you interact with this expert system? That is the GUI or user interface. Then, the expert system cannot operate if it doesn't have a software. Expert system software, which have the software have the following parts, or has the following parts. That is explanation of facility. It has the knowledge acquisition system and also the knowledge base editor. For now, for your level, just have this. But this one is an addition for content. State 3 examples of use of expert system. You can use it in medicine to provide diagnostic services. It can be used in mining to provide knowledge on availability of minerals when certain parameters are provided. Then to provide answers. It can be used to provide answers or clarity to uncertainties. Like for example, instead of bringing so many human experts, you can just use an expert system for that matter. Identify the following parts of VR, that is the virtual reality session. You can see this guy here. This guy has won some special stuff. We have part A, we have part B, and part C. So guys, I want you to identify these parts of virtual reality session. So part A is the graphs. These are the graphs. Then we have the headgear, and then the suit. So we call it the body suit. So this guy has worn graphs, has worn headgear, and bodysuit. Sometimes the headgear can be replaced with a bomb. Number 13. State some of application areas of VR or virtual reality. It can be used in military and space exploration to generate virtual environments for practices. So here the answer is military and exploration. in training to learn critical skills such as flight simulation for pilot trainees, in architecture to simulate how completed building would look like. Make sure you understand those 3 points. Then we have our second last topic. Our second last topic is called impacts or effects of ICT on society. So here, highlight 4 impacts of ICT on employment. What has ICT, how has ICT affected employment? So these are the answers. ICT has brought new jobs, that is job creation. It has made people to lose jobs, that is job losses. Some people have been displaced or moved to other departments. Like, for example, if you are in office, you are taken to be a soldier or a cook or a cleaner, that is job displacement. Then job productivity, on the other hand, ICT has made job productivity better. So you can pause the video and take some of the notes if you need to have more content on what I have explained. Highlight 3 negative impacts of ICT on human health. How has ICT affected our health? Number 1 is sleep disturbances. When you talk about ICT, we are not just talking about computers. We are talking about any ICT gadget, including mobile phones. So you'll notice that when you overuse your mobile phones, you may lose your sleep. That is sleep disturbances. ICT devices emit blue light, which can disrupt the body's natural sleep-wake cycle by suppressing the production of melatonin, a hormone that regulates sleep. You can read more on that. It has also led to repetitive strain injuries, RSI, for example, backache and wrist pain. You can talk about digital eye strain, headache, and then the sedentary lifestyle. Increased use of ICT devices such as computers, smartphones, and tablets often leads to sedentary behaviors as people spend extended periods sitting and engaging with screens. This lack of physical activity is associated with various health risks, including obesity, cardiovascular diseases, and musculoskeletal problems. So some of these ones can be brought to this point: repetitive strain injuries. Explain how ICT has affected our cultural, religion, and social values. Let me come up again. Explain how ICT has affected our cultural, religion, and social values. So, number 1, there is cultural exchange and globalization. You'll notice that people are stealing, in quotes, people are stealing other people's cultural activities or norms. We have transformation of cultural practices. You can see now something like a dressing style has changed since we see how the other people from other countries dress through the television and other social media. Impacts on religious practices. Then we have social interaction and relationship. We have privacy and ethics. So there is something like social engineering. There is other things that you can read from there. So for more scrutiny, just pause the video and then take some short notes. Identify at least 9 major breakthroughs today which would never have been possible without ICT. So we have e-commerce, we have e-learning, digital mobile networks, we have guided missile technology, development of medical technology like CT scan, space exploration, mapping of human genome, etc. So these are some of the breakthroughs that would not have been there if there is no ICT. State 5 current trends in ICT. So you'll notice that trends, when you talk about trends, these are the things that are really happening. Number 1, we are getting better softwares. There is rise of mobile phones. There is rise of wireless technologies. There is cheaper but larger memory capacities, that is of the computer memories. Computers are becoming smaller in size with more processing power, among others. You can add like 5 things. Lastly, we go to our last topic in Form 4, careers in ICT. We have careers in ICT. Careers in ICT. Let's just do justice here. careers in ICT. Careers in ICT. Guys, this is our last topic here. So, I just want you to explain around 10, there are more than 10 careers that has been brought by the ICT. The first one is software engineer or software developer. This is a guy who is responsible for developing and maintaining software applications. That is by coding, testing, debugging, etc. We have another guy called a network administrator. This one is used for managing organizations' computer networks. Then we have another guy called database administrator or the DBA. This is a guy responsible for designing, implementing, and managing databases to store and organize data efficiently in an organization. We have information system analyst, security analyst. This is a guy responsible for protecting an organization's computer system and networks from cyber threats. In Form 2, you can read about the cyber threats. Then we have a system analyst. This is a person responsible for identifying, that is the current system problems and proposing computerized, that is computer-based solution. We have IT project manager. This is a guy who is responsible for overseeing IT projects from start to compression or from start to the end. That is initiation to compression. We have crowd solution architect. This is a guy who is responsible for designing and implementing crowd-based solutions for organizations. We have IT consultant. This is an expert who is consulted on all IT strategy, technology solutions, and system implementation. We have data scientist. This is a guy responsible for analyzing large volumes of data to extract insights and information for business decisions. We have user experience designer, UX. This is a person who is responsible for improving the usability and accessibility of software applications and websites. We also have a computer teacher, you can add there, like myself. We have computer operator. We have salesperson. You can be employed to sell computers. You can also be a cyber guy. That is a self-employed guy. So guys, thank you very much for watching. This is the end of my presentation. Remember to subscribe. Remember to share the link with your friends or classmates. Also, to access the notes, you can just contact the given contact details there. Thank you very much.